Okay, Algebra 2, Set 5, Word Problems, Fractional Parts of a Number. Okay, so the first part, word problems. When you have word problems, this is a key thing to keep in mind. If you have one equation and one unknown, then it is solvable. If you have more than that, if you have two equations, then you should have two unknowns. Three equations, three unknowns, and so on. To obtain a unique solution, the number of equations has to equal or exceed the number of unknowns. Okay, and ideally, you should have the exact same number of equations as you have unknowns, because if you have if the number of equations is bigger than the number of unknowns, at least one of your equations is redundant, meaning you don't necessarily need it. So that's just something to keep in mind in general about word problems. Now we'll get a little bit more specific about these word problems. And to solve these, we're just going to go through some examples and then solve them and talk about how to solve them. Twice a number is decreased by 7, and this quantity is multiplied by 3. The result is 9 less than 10 times the number. What is the number? So the first thing that I see that we have twice a number is decreased by 7. So twice a number is decreased by 7, that's 2n minus 7, and this quantity is multiplied by 3. So we're going to multiply that whole thing by 3. Then it says the result. So the result is the equal sign, and it's 9 less than. 9 less than means we're going to subtract 9, then 10 times the number, so 10 times n. So now we have our equation, and we just need to solve it. Solve it for n to get the number. So we get 6n minus 21 is equal to 10n minus 9. Then subtract 10n from both sides, add 21, we get negative 4n equals 12. So n has to equal negative 3. Now on word problems, if you're ever unsure about the answer, you can always go and check it. So I just take that negative 3 and plug it back in. 2 times negative 3 minus 7 times 3. So we get negative 13 times 3, negative 39. And then we'll check the other side. 10 times negative 3, which is negative 30, minus 9 is negative 39. They both equal each other, so they check out. You don't always have to check, but if you're unsure, that's one way that I go back and check, because I just go back to the original problem and make sure that it all works out. Okay, the number of ducks on the pond was doubled when the new flock landed. Then 7 more ducks came. The resulting number of ducks was 13 less than 3 times the original number. How many ducks were there to begin with? So this one is a little bit more confusing, but the key phrase here that I'm seeing is where it says, whoa, I didn't mean to do that one, is where it says, let's just change that to that, the resulting number of ducks. So the resulting, that means that's going to be where you put your equal sign, because you have a before and then an after. So let's start with before. So with the before, we have the number of ducks doubled, and then 7 more came. So 7 more came, and then the resulting number of ducks, we have an equal sign. 13 less than 3 times the original. So 3 times the original minus 13. Then we just need to solve. So subtract 2n from both sides, add 13 to both sides, and we end up with 20 is equal to the number of ducks. Next example. The sum of negative 7 and 6 times a number is multiplied by 5. The result, so again, there's your result word, is 332 less than 3 times the number. What is the number? So the first thing I look at is it says the sum. So that means we're going to be dealing with a plus sign. So I start with that plus sign, and it says the sum of negative 7 and 6 times a number. So negative 7 plus 6 times a number, and the sum is multiplied by 5. That means we're going to take all of this, put parentheses or brackets around it, multiply by 5. Then we have an equal sign, and we have 332 less than. So if it's 332 less than, we're going to subtract 332 from 3 times the number. Now we can go ahead and distribute and solve. We get negative 35 plus 30n equals 3n minus 332. Subtract 3n from both sides, add 35 to both sides. We end up with 27n is equal to negative 297. And when we multiply that out, we get n is equal to negative 11. You can see that 27 goes into 29 one time, and there's going to be 2 left over, and then I just put those together, 2 and 7, that's a 27, so it's a 1 and 1. Kind of a fast way to do that in your head. Okay, so the second part of this lesson has to do with fractional parts of a number. It is word problems again, and just a reminder when you're dealing with word problems, when you have the multiplication sign, that means of in the word problems, and the equal sign is always is. So if you keep that in mind, that of means times and is means equals, then that makes these a lot easier. 1/5 of the clowns had red noses. If 30 clowns had red noses, how many clowns were there in all? So 1/5 had red noses, and 30 clowns have red noses. So we know that 1/5 of the clowns, so 1/5 of the clowns is 30. So again, of means times, so 1/5 times c equals 30. We can solve from there, multiply both sides times 5, and we get 150 clowns. Okay, and our last one, 7/8 of the Tartar horde rode horses. If 140,000 were in the horde, how many did not ride horses? So we're going to start this one off because it says 7/8 of the horde rode horses, but we're wanting to know how many did not ride horses. So if 7/8 of the horde rode horses, then that implies that 1/8 of the horde did not ride. So we're dealing with 1/8 of the horde, and then it said that the horde was 140,000. So 1/8 of 140,000 is going to give us our number. So we just have to divide 140,000 by 8. When you divide 140,000 by 8, you end up with 17,500 that did not ride horses. Excuse me.